Looking good. Excellent, thanks.
Okay, yeah, thank you for the introduction. So let's talk about self-extensibility for modeling languages. Well, what does this mean? So in general, this means the possibility of a language to extend its concrete capabilities on the implementation level. So this actually originates from programming. Just think of Java or Python, so which are okay or even good languages, but what makes them really great is there are vast libraries that you can continuously employ, but also extend, and this on the programmer level. And this is what we are currently investigating in our work, but of course in terms of modeling. So there is this general trend of adopting all the concepts we already know from programming and transferring them to modeling. It's not exactly the same, but the concepts really apply. You just have to have a look at how are you actually employing them in the constraints or in the world we have at modeling with further abstraction and so on. And here, the overall goal is to making this shift to extend a language from the language level towards the model level. But first of all, why do we need this? Only just because, well, programming does it sounds kind of a weak statement. However, think of situations where you have some basic modeling languages or some basic modeling elements which are just structural elements or behavior descriptions that can be plugged together, something like this. And of course, as a modeler, you don't want to reuse them every time from scratch for each model, but you want to rely on things you already did, so to reuse these, well, let's call them basic building blocks. And how would you do it without an extension mechanism for your language? Well, one day, of course, of solving this would be just going to the language engineer, say, hey, I developed this concept. I need this in my language present for all my modeling endeavors. And yeah, you could actually do this. But this, of course, yields several issues. Let's get through them pretty quickly. So first of all, doing that over and over again would pollute your grammar or meta model or whatever kind of tool you're using to define your language. So in case of a grammar, it gets longer and longer and longer the more concepts you add. And just to be sure, you add more capabilities of the language, but you're not increasing the expressiveness. This stays the same. It's just providing usability for the modeler. But as a language engineer, just for that, I don't want to stick around with a 20,000 lines of code grammar. It isn't maintainable anymore. So this can't be what we actually want. Another issue of directly doing this inside our language definition is, well, we are kind of losing backwards compatibility. So think of keywords or just syntactic phrases which were just okay in your previous version of the language. And in the next version, well, this is now an occupied keyword. So all the models that uses this by name, just by chance, are invalid now. And well, experience shows that modelers tend to directly occupy intuitive names. So the chance is actually pretty high. And well, if you don't believe me, think of the assert statement from Java. There was a time where this wasn't a keyword. Maybe not all of you remember, but JUnit definitely does remember, because they had to change their complete infrastructure, because this is how the assert method or the check method looked before. They had to change it. Nowadays it looks like this. It's just a renaming, so it's not the end of the world. But it can break stuff. This is all I want to state. And there's also a third problem, and this is when you extend the language further and further with all different concepts, you might even end up with clashes between these concepts. So just think of the functionality where you want to check the volume of an object. So what's this volume? What's the volume of this speaker? Could be this. So it's around 0.3, 0.3 and a meter, so 0.3 square meters as the volume. Yes, perfectly fine, but it's a speaker, so maybe we would have expected something like this. Of course, I made this up, but I just want to say, yeah, when we integrate more and more in our language, even cross-domain, then we'll end up in hell because we cannot distinguish all of these. Yeah. So now let's think of traditional language extension mechanisms. Because, yeah, we developed them and they're good, so don't get me wrong, they are pretty important just for reusability on the language level. However, this is not exactly what applies here. So if we have the same situation, we have our base language developed with feature A, feature B, feature C, all with new language variants of this. Can do this? Fine. And now I'm the modeler. I want to have a language with feature A and feature C, or with feature C and feature B, or with everything involved. So we end up with all these variants, and it might still be the case that a modeler only want this or only want that. So now we end up with a software product line of 8 of these languages, which we all have to maintain. So this can't be the way. This is not what we want to do when it's just about we have basic building blocks which can be created on a modeling level that we copy them over into the language. So this is just the motivation why we need this self-extension mechanism also on the language level. Don't get me wrong, not every modeling language needs that, but there are some where it's quite handy. And I have also an example later on where we exactly faced the problem of ever-growing language. So yeah, here we are again at the illustration from the first slide. So when it's just about adding these building blocks, we don't want to add them here. So not feature B, C, and so on, which I just showed you. You can do this for 1 or 2, even for 10, but not for 1,000 or something like this. What you actually want to do there is add one generic extensibility feature, which then can be incorporated at model level, and other models can refer to exactly this extension feature or this implemented extension feature. This is actually the way to go for these particular kinds of things. So yeah, and we're not the only ones dealing with that. One of the other ones is sitting behind. So yeah, this is from Ed, who also discussed this topic in the paper of the Metasemantic Protocol for Modeling Language Extension. And yeah, overall, just to show there are particularly people working on that, and I think you did it in the context of SysML v2 back in the days. And the basic thing is you need several properties which your self-extension mechanism has to fulfill. It's what was quite in a similar direction, not the same language or something like this, but yeah. So what you actually need is, of course, first the formal semantics for, well, describing these intricate language extension, then the abstract syntax actually allowing the extension for employing the external artifacts, and finally the concrete syntax enabling the modeler to make the extension possible. Basically, and I'm here reusing a slide of myself from models, what you actually need is some kind of import mechanism to refer to external artifacts in combination with an instantiation of a generic feature which then can be employed. So usually it's similar to this type-object relation or type-instance relation. You have some defining place and you have a using place. And these, in combination with this cross-referencing or import mechanism, actually enables you to bring this self-extension mechanism to life. Okay, now let's talk the actual case study we did this on. And this was the example of GUI DSL, how we call it. So it's just a small language to describe the web front end of, well, yeah, web applications. So what it does is it describes the structure. and it generates HTML, CSS, and TypeScript to generate such pages. And what I described in the beginning, we actually faced within that language. First of all, we kind of were a little bit naive and started with the language, added text, button, maybe image, video, and so on, list of 30 elements. Was nice, was pretty handy to use, everything fine. However, quickly we reached a situation where we needed another graphical element, then another one, then we needed one we already had, but a different variant of that. And also then we needed, well, everything we already have, but composed in some kind of situation because we don't want the same arrangement all over again. Yeah, and there exactly we were. The language was ever growing, the grammar gets longer and longer, and there we said, stop, this cannot be the way. And yeah, all what I presented you in the beginning. So there we made the decision, okay, we need to externalize this thing. So here is also what we did. So you don't have to exactly read the grammars, but first of all, what we had is the DSL version 1, so without self-extension mechanism, and the version V2 with self-extension mechanism. And while the first one had this list of button, text, and so on, the second one only had control structures. So here you just said, okay, I have a component declaration with a keyword component. I can give it a name, several attributes, and so on. And I have a usage, so component usage where we just made this up with this @ sign, can indicate, okay, now I'm instantiating one of these defined components. And of course, the model world is getting broader through that. Don't get me wrong. So it usually creates a little bigger models. And you see this here. So you cannot directly use the button or the text. First of all, these things have to be defined, then imported, and then you can employ them here. But if you skip the import statements, because I mean, usually in IDEs you don't care about them, you just hit your keys and everything is imported. It's basically the same, but with the difference that these are not defined here, but here at the model level in distinct artifacts. And yeah, this is actually what it's all about, to create this kind of model library, to make all of these things available via the language, but extensible on the model level. So it also opened the way to exactly have these weird combinations I showed you in the beginning. Because if I have it at the model level, I, as a modeler, can make the decision to incorporate this volume function of my soundbar and not of the spatial representation or something like this. This is just a decision I, as a modeler, can do, and this is perfectly fine. Okay, and what we also did, we applied our new DSL at a project we did at RWTH at our chair, and yeah, this is what we built. So our use case was Makoko. It's the management cockpit for controlling. It's basically a tool or a web tool which supports the administration of an institute to manage employees and finances. This is actually really a project we had at RWTH, and it's currently in operation. And for instance, the money which lets me travel here is administered there. So I'm happy this works, otherwise I couldn't be here. So however, this project, or the front end of this project, was still originally developed with GUI DSL 1. So we implemented, or we re-implemented certain parts of it with our new DSL just to compare the results, to look, okay, we were pretty confident that it will work, but maybe it works in a way we could not ever imagine, and this is total crap. But yeah, so we first started off with the staff page, and on the left you see the GUI DSL 1, and yeah, here on the right its successor. And yeah, I don't expect you to understand it perfectly, but from just the visual representation, you see, first, it looks kind of similar. However, this side is a little bit more verbose or a little bit more obscure. First of all, this is just the reason we added a kind of prefix for our library, but this is just our decision. So you can imagine this gem just to be non-existent. But overall, the structure of the models is really similar. The real difference is, well, the concrete syntax you need for instantiating an object. And we also decided, but this was not directly related to self-extensibility, to have these attributes available via direct name assignment. We hadn't this there. But overall, this is a little bit more verbose, but seems to be quite applicable just in terms of a comparison. Okay, so we can create pages similar to what we could do before. Next, we had a test related to the general overview pages. So in the first version of the GUI DSL, we had to rebuild these from scratch ever and ever again. And here we faced our first real advantage, because what we now did in GUI DSL v2, we just defined the overview page, because the structures all the same every time. We once defined them, only incorporated them. So the lines of code, although it's not a perfect measure, is not really that different. However, we could reuse this. And if you think of that there is much more behind it than just the model, but also the HTML, CSS, and TypeScript, which is by default generated, but you always need some further tweaking or something like this to have a nicer style, you only had to do this once, and not every time over and over again. So here we had our first real advantage, just to reuse a component we composed on the fly. Yeah, and then we can do this even further. So we took this component and introduced it within our modeling language, or in our model library, sorry. So we took the component, put it into the jar together with the generated sources, the handwritten extensions, and well, what we call, most of you might be familiar with it, the symbol table. Often it's not explicit. We in Monticore, where we develop our languages, it is an explicit file which we can store. It just helps us cross-referencing and directly checking when employing a new artifact whether everything we need is there. We don't need to process the whole original model again and again. But this is just a slight improvement for efficiency. So what we have there, we have the package jar with the model, with all the generated and handwritten artifacts. Also, maybe with additional artifacts, sometimes it's necessary, just think of default images or something like this. You can all package it, and you can just access it via your normal, or in your normal modeling endeavor. So let's compare the overall processes we had before. So before, if we had, always have in mind, we have a modeler with well, some idea in mind and want to reuse a certain component. First, the model developer had to go to the language engineer to add a component. Then there were several iterations of adapting the component just to make it fit for all the different use cases, which, to be honest, was okay for us, because at our chair we all, well, sit next door, but in a realistic scenario, your language engineer does not sit next to your modeler. So this could lead to pretty long iteration cycles, and you just want to get your product done. So you cannot wait for this. And this is a little bit relaxed here on the right-hand side with our version of the GUI DSL with the self-extension mechanism, because the barrier, or we don't have the language engineer involved in defining these components, but we have the so-called library developer. And this role can be anyone, to be honest. This softens a little bit the barrier between these meta levels, just because as a language engineer, I could provide a library, and to be honest, I should if I provide the self-extension mechanism. But I also enable my modelers, who are pretty proficient within these things, to provide their components themselves. And this is actually the main difference in the process we achieved here. Also, a small comparison in terms of numbers. I already said it, lines of code are a bad metric, but we also looked at that. So to provide the discussed GUI component of our case study, generally via the language, first we required, of course, to alter the language. This is not anymore the case. Then we had to alter the generator, which is also not the case. But of course, now we have to do this on a model level. And okay, this is a little bit lower, but I don't want to go in numbers. This is not really what we have to compare here. What's more important here is that we see we don't have to alter the language anymore. We don't have to alter the generator, just the model and some handwritten extensions. By the way, the reason for this number being higher than this is just because here we had to do lots of changes in the generator, which also enabled us to generate more. But yeah, just to explain the differences, it's not that always in this new case you have to code more. Okay, but overall, you could also see that the number of lines of code in total are a little bit decreased. Lastly, coming to a more qualitative observation. So, of course, with respect to the scenario that we are currently in, wanting to make basic functionality which we can model locally, globally accessible via the language, then we had the first observation, okay, we have actually a more intuitive language definition, so a grammar in our case, with the self-extensibility, just because our language didn't blew up. Then this conservative extension, so extending the language without destroying old models, is possible here because, well, the modeler can decide to import something or not. On the left-hand side, there are ways around it, but this even makes your grammar worse or harder to maintain. What you have to say is that if you only rely on in grammar definitions or in language definitions, it most likely has a little bit of a prettier syntax, because here you have to make this distinction between definition, usage, and you have to make them somehow present or to somehow give the modeler the possibility to make this decision. But yeah, for us it was a single @ sign. And what's also on the plus side, we enable the modeler actually extending the language. Well, all the thing I just discussed, this was the reason. Of course, this also has a risk of burden modelers with the technical level, because when I, as a modeler, extend my language, maybe I have to provide some handwritten extensions for the component. This is just the case. It's not always the case, therefore I put it in brackets, but I would say that's a good enough trade-off because, first of all, it's not always the case. Second of all, well, we actually wanted to provide the modeler with the capabilities, so sometimes it's necessary that the modeler who actually wants to do this is the more proficient modeler, I would claim, is capable of doing that, or at least of having the knowledge. Thank you.
Thank you very much. We have some questions from the audience. That's a bad place to stand. Well, let me kickstart again. You're familiar with the work of Jim Cordy on TXL?
TXL, I heard of it, yes, but yeah. Maybe help me out again.
Yeah, TXL worked by basically extending languages by doing source code transformations. So you specify the base grammar and then the extended grammar and do transformations. Of course, the target languages are programming languages which tend to be Turing complete, so you can always do that. I guess in your case, the target language is not necessarily Turing complete.
Not necessarily. It can be, but doesn't have to be yet.
So how would you compare the approaches? How far do you think you could get with source code transformation? Because Cordy managed to do quite a lot with it, but again, the target is a little bit different. It's just
it's a pretty good question. Let me think about it for a second. I would guess he's a little bit more flexible with that, to be honest. So we are still relying on mechanisms we have to provide also on a language workbench level, to be honest. So all these you can implement everything in the language, but you want to provide some handy functionality for your language developers as well. However, in terms of, let's say, expressiveness, as you just said, Turing complete, you could very simply always achieve something which is Turing complete. I would just guess that we have to put some more work into it.
Okay. Question from the audience yet? Then I'll ask the standard question that I asked before. How easy is this to apply in other contexts? I mean, this is for your framework, but if somebody wants to do something similar.
We can do this easily for all the languages in our ecosystem, of course. Well, the concept we described, you can really re-implement pretty easily. However, you have to re-implement it. So our source code is usually based on Java. So if you just take, for example, xtext, it's not that hard of applying it there, because you can really read it and transform it just to the kind of AST they have there. However, not every language workbench or not every language ecosystem, so to say, is as equal as that. So, well, MPS is also on Java, but it's more closed world. So here you would have to put a little bit more work into, and I would guess if you think of Neverlang or Rascal also, there you really have to not redo the concept. They still apply, but you have to do more thinking of how to apply the concept on the specific ecosystem. So currently it's in our language world, or language workbench ecosystems world. It can be applied, but not without additional work.
Okay, thank you. A question?
So you had this nice overview where you showed advantages of disadvantages versus in with self-extensibility or not. Maybe a bit of a controversial question. Is it always a disadvantage that only language engineers can modify the DSL? So this reminds me of Haskell, where there's lots of language extensions, and only language engineers can create new extensions, but it's already too much and hard to handle. So if I can create my own, every developer has another language in the end. So isn't it too challenging?
This is perfectly fine question. This not only applies to the point you just said, but to all of them, only counts for the situation I just described. So if you have constant model capability of providing components that you want to reuse, but you cannot always go to the language engineer, then this evaluation applies. Not in general. I mean, if you have a Hello World program, I would not provide it with self-extension mechanism. Yeah, so it's only in the context I just presented. It's also what I said in the beginning. So I don't want to throw away language composition techniques we developed over the years. I put a lot of work on them. I don't want to lose them. It's just for this kind of scenario.
Okay, we're at the end of this this slot. So let's thank Nico once more.